Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, IIT-Jam, Jest, Tifr and other exams related to physical science. Okay, so this is the lecture number 2 of condensed matter physics. Okay, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so in previous lecture uh, I had to end the class because of technical error. So I'm going to continue from where it was left. Okay, so this is the second lecture guys of condensed matter physics. Okay, and I apologize for the previous lecture. I had to end the class because of technical error, so I apologize for that guys. Okay, so we have studied that crystal structure, Brevis lattice and the condition, right? And also lattice, uh, primitive unit cell, that was also studied in my in the previous lecture, right? And Brevis lattice, right? So now we are studying this crystal structure, types of crystal structure. Okay, so first is, and meanwhile just let me check whether I'm audible or not, that is also important. Of technical error, yes, I'm audible, so I'm going to proceed further. Okay, okay, so crystal structure we were studying. Okay, this is the second part of crystal structure. Okay, crystal structure. Okay, so we'll study first simple cubic. Okay, simple cubic, simple cubic, that we can say SC as well, simple cubic. Okay, I'll make a diagram as well. Okay, so this is simple cubic, guys. Okay, these are the atoms at the corner of the cube. Okay, so here for this and also we know this formula guys, you need to know that how to get n effective. Okay, n effective, that is effective number of atom. I have already explained in my previous lecture, that is nc upon 8 plus nf by 2 plus ni. Okay, so this is the nc means the atoms in corner. Okay, nf means the atoms on the faces of the cube. Okay, and ni is the atoms at the center of the cube. Okay, okay, this is the formula for simple cubic. The n effective is going to be n effective, that is effective number of atoms. Okay, so n effective is going to be this one. So there are 8 atoms in the corner, right? So nc upon 8 means 8 upon 8, right? So this is going to be 1. Okay, and so the simple cubic is because I have already explained what is primitive unit cell, right? So it means the simple cubic is primitive unit cell. Okay, primitive primitive unit cell, primitive unit cell. Okay, now for this coordination number. Okay, coordination number. Coordination number. What is coordination number? I'll explain it. Okay, coordination number. Coordination number. Okay, coordination number is number of nearest neighbor. Okay, number of nearest neighbor. Okay, that is number of nearest neighbor. Nearest number of nearest neighbor. Number of nearest neighbors. Okay, and for is 6 guys for this, for simple cubic. I'll tell you a trick in the last as well, so that you can easily uh, learn those coordination number. Okay, the number of nearest neighbors, number of first nearest neighbor, number of second nearest neighbor, number of third nearest neighbor for SC, BCC and FCC crystal structure. Okay, so as of now, okay, so coordination number for coordination number is 6 for simple cubic. Okay, number of nearest neighbors. Okay, second is second number of second nearest neighbors. Okay, number of second, these are number of first nearest neighbor. Okay, second second nearest neighbor. Okay, number of second nearest neighbors. Okay, these are 12 for SC. Okay, simple cubic. SC means simple cubic. Okay, at which are at distance root 2a guys. Okay, is the side of the cube. Okay, root 2a. Next is third nearest, number of third nearest neighbor. Number of third nearest neighbors, and that is 8. Okay, at a distance root 3. Okay, so these are the coordination number, or the number of first nearest neighbors, number of second nearest neighbors, number of atoms, that is third nearest neighbors. Okay, so this one, and now I'll show you front view of simple cubic structure. Okay, so front view of simple cubic structure. Okay, front view of SC structure. Okay, how it looks. Okay, this one. This. Okay, so front view of this is this is square. Okay, so this is so the radius of this square, this circle is R. Okay, this is R. Okay, and the side is A. Total side is A. Okay, this is R. Okay, so from here the atomic radius, these are atoms, and this is square. Okay, so front view of simple cubic is this. Okay, so atomic radius, from here it's from figure it's clearly seen the atomic radius A equal to 2r, right? Because this is the radius of atom, right? R plus R is total A, right? A equal to 2r. Very important, guys. You need to know it. You'll solve questions. Okay, We'll solve questions. So this is important for simple cubic. The side of this is equal to 2r, the radius of atom. Okay. Next. Next is volume of unit cell, that is volume of unit cell of simple cubic crystal. Okay, so volume of unit cell, volume of unit cell. So that is a cube, guys. Okay, a cube means 2r cube, right? Because a is 2r, right? So this is going to be 8r cube. This is the volume, a cube or 8r cube. Okay, so now we'll find atomic packing fraction, guys. Okay, atomic packing fraction. In short, we say APF. APF. So atomic packing fraction is that is we know the formula. You need to note down. Okay, so this is n effective number of effective atom. Okay, into volume of each atom. Volume of each atom upon volume of unit cell. Okay, volume of unit cell, volume of unit cell. Okay, this is important. Okay, so this is the packing fraction, guys. Okay, very important formula. I have already explained crystalline solid, non-crystalline solid, lattice, brevis lattice, and 2D brevis lattice and crystal structure in my first lecture, guys. So I would request you watch that. And I had to discuss. I had to end the class that time because there was a technical error. So remaining part I'm continuing in this lecture, in second lecture. Okay. So crystal structure will get completed in 2 lectures. Okay. So this is the this is the atomic packing fraction for the simple cubic structure. Okay, so effective number of effective atom into volume of each atom upon volume of unit cell. Okay, so this is the front view of simple cubic structure. So from this view, it's clearly seen the radius, that is the atomic radius. The relation between atomic radius and side of the cubic structure is A equal to 2r. Okay, very important one. You must know it because there are many questions. You will be able to solve it using this will be used. Okay, well, next is so now we'll find out the atomic packing fraction. Okay, so APF, I'll write in short APF, that is going to be, so for simple cubic effective number of atom is 1 into volume of each atom is, we know the so these are spherical, right? So 4 by 3 pi r cube, 4 by 3 pi r cube, 4 by 3 pi r cube. Okay, so 4 by 3 pi r cube, r is the radius of the atom. Okay, and volume of unit cell is a cube, right? A cube value is 8 r cube. I have already explained this here. A cube equal to 8 r cube, right? We have put the value r cube will get cancelled, 4 will cancel this 2 times, right? So this is going to be pi by 6. Okay, and this value is going to be almost equal to 52%. Okay, so this is not closed packed structure, guys. Okay, I'll tell you the what are the condition for being closed packed structure, right? I'll tell you that as well in the later part. Okay, so well, okay, so this is 52% atomic packing fraction. Okay, next is BCC crystal structure, yeah. body centered cubic structure. Okay, body centered cubic structure, body centered cubic, we can write BCC. Okay, so for body centered, we'll first find an effective. Okay, and effective, and effective. That is effective number of atom for body centered. I'll make a figure. So this is the body centered. Body centered. Okay. So 8 atoms at the corner of the cube. Okay, and one atom at the center of the cube. Okay. So for that, N effective is going to be 8 corner 8 into 1 by 8, right? Plus 1 is at the center, right? So this is 1. Okay. So this is going to be 2. 8 8 will get cancelled. So effect for body centered cubic, the effective number of effective number of atoms are 2. Okay. So there are 2 atoms. Okay. Next, number of nearest neighbors. Number of nearest neighbor means first nearest neighbor. Okay. Number of nearest neighbor. Number of nearest neighbor. Number of nearest neighbors, that is coordination number, right? For BCC uh, it is 8. Okay. Next is this one. Okay, number of nearest neighbor is 8. At distance root 3a by 2. Okay. Okay. Third point is second nearest neighbor. Okay. Second nearest neighbor. Second nearest neighbor. Second nearest neighbor equal to 6. Okay. So number of second nearest neighbors is 6. Okay. That is third nearest neighbor. Third, I'll tell you the trick as well. Okay. Third nearest neighbor. Third nearest neighbors equal to so a number of third nearest neighbors equal to 12. Okay. At a distance root 2a. Okay. Next is we'll find this atomic this front view of BCC. Okay. So or atomic radius of BCC. Okay. Front view of BCC. Okay. So this is important, right? So this is going to be like this. This is the one, guys. Okay. So this is the front view of BCC. Okay. So this is the center. This distance is root 2a, guys. This you need to understand. This is a, and this distance is root 2a. Okay. And this is the one, right? So this is r plus r, r and r, right? So these are 4r, right? So from here, front view of this is for BCC. Okay, this is rectangle between here, right? So this is this distance is root 2a, this distance is a. Right? Okay, guys. So here you can find this. From here we can see 4r equal to root 3a. Okay, because this value is root this one, right? This value is going to be a square plus root a square plus 2a root square, right? Root 2a square. So that is going to be root 3a, right? And this distance you can see, this figure is not looking exactly right, but this distance is r. This is also r and r, 4r, right? So for BCC, the radius, the relation between radius and side of the cube is 4r equal to root 3a. Very important, you need to note down, guys. Okay. Well, so this is the one. Now volume. So now we know the radius. Now we can find the volume. Volume of unit cell. Volume of unit cell. Okay. So volume of unit cell is going to be a cube. A cube means 4r upon root 3 whole square. Because we know this relation, guys. Okay. 4r equal to root 3a. Okay. So this is the answer. So from here we can easily find value of a is 4r upon root 3. Okay, so 4r upon root 3. Now we'll find atomic packing fraction for BCC. Atomic packing fraction for BCC. So that is going to be that formula I have already explained, right? N effective into volume of each atom upon volume of unit cell, right? So this is going to be N effective for BCC is 2, volume of each atom means 4 by 3 pi r cube upon volume of this a cube, right? Unit cell. So this is 4r upon root 3 whole cube, right? This is cube, guys. Okay, so we'll solve it, and this value is going to be root 3 pi upon 8. Okay, root 3 pi upon 8, right? And this value is almost equal to 68%. Okay, 68%. Okay, so this is this is about BCC, body centered crystal structure. Okay, BCC crystal structure. Okay, now we'll study FCC. Okay, FCC, that is face centered. Okay, so for face centered, first we'll make a figure. Okay, this is the crystal structure of face centered. Okay, FCC, or right, face centered. Face centered cubic structure. Okay, face centered cubic. Okay, in short we say FCC, face centered cubic structure. Okay, so this is like this. This is the face centered, guys. Okay, so there are 8 atoms at the corner for face centered crystal structure. Okay, so these are 8 at corner, and 6 atoms are at the face of the crystal. Okay, so this is the figure for face centered cubic crystal. Okay, so for this N effective is going to be N effective is going to be and effective is going to be 8 corner, right? 8 into 1 upon 8, 8 into 8, 8 into 1 upon 8, okay, then plus this one. So there are 6 atoms face center, so by 2, right? Because we know NF by 2, so this is the formula, guys. I told you this one. NF equal to NC by 2, corner atom, and NF face atoms, right? By 2 in Ni. Ni is it, and if number is at center, that atom is at center, okay? So this is going to be 8, it will get cancelled, so 1 plus 3, that is 4. So N effective for FCC crystal is 4, okay? Next, so coordination number, that is coordination number, that is first nearest neighbors, number of first nearest neighbor, okay? Coordination number. Coordination number, coordination number is 12, okay? Now second nearest neighbor, second nearest neighbor, second nearest neighbor is 6, okay? Third nearest neighbor, third nearest neighbor, third nearest neighbors is 24, okay? So now that atomic radius for atomic radius or front view of FCC crystal, okay? FCC, or we can find atomic radius, okay? So front view. So this is going to be like this. Okay, this is square, guys. This value is A and this value is also A, guys, okay? And this is R, this is the center, this is R, this is R, this is R, this is 4R, right? So from the figure, this is A, guys, okay? This is R, this is center, this is R, this is R, and this is R, okay? So this value is from figure, we can see this is 4R equal to root 2, because this value is 4R, guys. So this you can see from the figure, R, 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 and R, 4R. And this value is also root 2, right? So because this value is A, this value is A, right? This is the hypotenuse. These are height and base. So hypotenuse equal to root height square plus base square, right? So that's why 4R equal to root 2A. In case of BCC, that is 4R equal to root 3A, right? Or in case of SC, that is A equal to 2R, okay? So also in case of this FCC, this is 4R equal to root 2A. Very important, you need to note down, okay? Now we'll find out atomic packing fraction, APF. APF is, that is number of effective atom into volume of each atom upon volume of unit cell, right? I have already explained this, right? So this is going, so for FCC, the effective number of atoms are 4 into volume of each atom is 4 by 3 pi r cube upon this one, this is 4R, and this is volume of FCC crystal is A cube, right? A cube is from here, what is the value? That is from this relation we can get the value of A. A is 4R upon root 2, right? So we can write, 4R upon root 2, right? So here, sorry, my apologies. So we can get the value of A, value of A. So value of A, this is going to be this one, a upon 2 root 2 whole square, right? So this value is going to be pi upon 3 root 3, and this value is going to be almost 74%, guys. Okay, so this is a cube. A cube we can also find out from here. Okay, so from a value is going to be this one, 4r upon, there is r as well, right? R cube, right? So this is 4r upon 4r upon root 2, right? So this is going to be 4r upon this, right? So from here we can get value of a. So this value is going to be 2 root 2 this one. Okay, this is the value. So we'll put the value, so we are going to get 74%, guys. Okay, well, so this is the a cube. I think we have this is the wrong we have written. Okay, this is going to be a cube, right? A cube is this one, 4r upon root 2 whole cube. Okay, so this value is almost equal to 74%. Okay, so this is guys closed packed. Okay, this is, it's a closed packed structure. Okay, it's closed packed structure. It's closed packed structure. Okay, now there is a condition for being closed packed structure. Okay, so what are the condition for being condition for being closed packed structure? Condition for being closed packed structure. Okay, so this number one condition is, number one, atomic packing fraction APF must be greater equal to 74%. Okay, number two, coordination number, that is the nearest number, the number of nearest neighbors. Okay, coordination number must be greater equal to 12, and number third condition is n effective must be greater equal to 4. If any crystal satisfies these three conditions, then that crystal is called closed packed structure. For in the case of FCC, we can see the atomic packing fraction is greater than is equal to 74%, right? And also we can see the coordination number is 12 for it. Okay, and the n effective is also 4, right? So it means this FCC structure is closed packed structure. Okay, okay. So now I'm going to tell you the trick. Trick is how to remember those coordination number, the number of first nearest neighbor, number of second nearest neighbor, number of third nearest neighbor. Okay, for SC you can say, for SC you can you need to know, you need to learn STE. Okay, for BCC you need to learn EST. Okay, and for FCC you need to know, you can easily find out. Okay, you need to know TS24, 24. So this means for SC, STE means the first the number of nearest, the coordination number, right? The first number of first nearest neighbor is S means 6. Okay, S means 6, T means 12, E means 8. Okay, so this means 6, 12, 8. Okay, it means EST means 8, 6 and 12. Okay, and this TS20 means T means 12, S means 6 and 24. Okay, and 24. You just need to know, you just need to memorize this thing, guys. This one, 6, right? This is STE and EST, right? STE, EST and TS24. Just remember it. Okay, STE, TST. Sorry, my apologies. STE, EST and TS24. Okay, STE means for SC, right? For SC, STE. STE means that is 6. The coordination number or nearest neighbors are 6. The first nearest neighbor are 6. Second nearest neighbor are 12. Third is 8. And for BCC it's EST 8, 6, 12. And for FCC TS24. So you can also note down like that also, or you can also memorize like that, or you can make your own way of learning those things, right? So this is about the crystal structure, guys, right? So we have studied in first lecture, I have already explained. We have studied lattice, crystalline solid, non-crystalline solid, Brevis lattice, crystal structure, primitive unit cell, right? Uh, and uh, and in second lecture, because that time there was technical issue, and that's why I had to end the class. So here we have studied SC structure, FCC structure, BCC structure, right? So now I'm going to solve some questions. Okay. Okay. Question is very important question. These are atomic packing fraction related questions. The first question, which is asked in CSIR net, okay, 2018. So that I'm going to solve first. Okay. Question is CSIR net 2018. Okay. Question is a flat surface, a flat surface, a flat surface is covered, a flat surface is covered with non overlapping discs, okay, of the same size, okay. What is the largest, what's the largest portion, what is the largest portion of area that can be covered, that can be covered. Okay, so this is the question. A flat surface is covered with non-overlapping discs of the same size. Okay, what is the largest position? What is the largest portion of the area? Largest portion of the area that can. Okay, these are the options. I'll solve it. Just wait. Okay, guys, we have made some mistake here. It is no, it's correct, guys. Sorry, my apologies. That's correct. Yeah. Next. Okay, so question is a flat surface is covered with non-overlapping discs, okay, of the same size. What is the largest portion of area that can be covered? That area. Actually, it is asking about the atomic packing fraction. Okay, so a flat surface is covered with non-overlapping disc. Okay, so there is a. I'll make a figure, then it will be clear. Okay, so. So figure is this one. Okay, this is the flag, right? And we can make again. Okay, so now we have to find out what is the largest portion of the area that can be covered. Okay, so we have to find the atomic packing fraction. So this is the flat is these are the discs, non-overlapping discs of the same size. Okay, and they are arranged in this way. So we need to find out the largest portion of area that can be covered, means atomic packing fraction. Okay, so from here, like you can say this one. You can make a hexagon here. Okay, hexagon. These sides are A, guys. Okay, and clearly you can see these sides are A. You can see these are R, right? R radius of these sphere, right? Discs, we can say. Okay, so you can see A equal to 2R from here, right? This is the center. So figure is not looking exactly, but consider the figure. Okay, it is not looking exactly. So this is a hexagon, guys. Okay, consider it hexagon. Okay, it is a hexagon, and we can see A equal to 2R from the figure. It is clearly seen because this total distance is A, right? So this is the radius, this is the radius. R plus R equal R, A equal to R plus R, right? This one. So now so we have to find the packing fraction, right? Atomic packing fraction, APF. So this is going to be that is the first we'll find this one, area covered by disk. Okay, first area covered by disk, area covered by disk. Area covered by disks, that is going to be, you can see area covered by disk is the angle between hexagon, right? You can see here these are 120 degree, right? These angles are 120. So area covered by disks is going to be, so these in this hexagon, area covered by disk. So this disk, this disk, this disk, this disk is this, right? So this is going to be, this is going to be in hexagon, area covered by disk. Okay, so this one, this, so this is going to be, angle is, this is the value 120 angle upon total angle is 360 into, that is effective number. Okay, into so how many atoms are there? 1 2 3 4 5 6, right? 6. Okay, 6 plus effective number we are getting, right? This is 1, this one. Okay, pi r square. Okay, so area covered by disk inside the uh, hexagon is going to be this one, because this is the effective number. Okay, these are at the corner. Okay, so the angle of hexagon, we know that is 160 120. So 120 upon 60 into 6, because 6 atoms are at the corner, plus 1 1 is at the center, plus 1 pi square. Okay, so you can say this is an effective plus pi r square, right? This is the area covered by disk, right? So this will get cancelled. So this is going to be this one will cancel, 3 2 2 plus 1 pi r square, and this value is going to be 3 pi r square. So area covered by disk inside this hexagon is 3 pi r square. Okay, now area of hexagon will find, area of hexagon, area of hexagon, area of hexagon is going to be what? This is going to be, we can see here, right? This is made of 6 equilateral triangle. Okay, you can see like this, 1 2 1 2 3 4 5 6, right? 6 uh, 6 equilateral triangle, right? So area of hexagon is going to be 6 into we know the area of equilateral triangle, right? Root 3 by 4 a square, because there are six equilateral triangle inside the hexagon, right? So it is going to be 6 into 3 by 4 a square, right? R square, my apology, R square, because R is the side, right? R square, this one, a square, guys, my apologies, a square, okay. We'll solve it. So this is going to be uh, 6 root 3 by 4, and this value is a square is a equal to 2r. From here you can see a equal to 2r. So this is going to be 2r square, right? So this value is going to be 6 root 3 r square, because 4 will get cancelled. 2 whole square, right? 2 whole square. So this value is going to be this, right? Now we'll find atomic packing fraction, APF, right? So this is going to be this one. APF is the area covered by this area covered by disks upon area of hexagon, right? So this is 3 pi r square upon 6 root 3 r square. R square will get cancelled, so this value is going to be pi upon 2 root 3. Okay, this is the answer, guys. So which option is matching? Pi upon 2 root 3. Option B is matching. Pi upon 2. So this is a good question, guys. Okay. So this we have been given. We have drawn the hexagon here, right? And by that we have found the APF, and that's what is asked in the question. Okay. Next question. Next question is question second. This question is okay. This is R. Okay. So this is the question given. This is R, and this complete value is A. Okay. This is given, and we need to find out APF, atomic packing fraction. Okay. So how we are going to get APF is area covered by disk, area covered by disk in the same case, right? Area covered by disk upon area of the hexagon. Area covered by disks upon, in this case, area of square. Area of square. Area covered by this hexagon. Okay. Area. So my apologies. Area covered by this disks inside the this one, inside this square. Okay. So area covered by disks inside the square upon area of square. So area covered, we'll find out that we know, right? So angle is 90 degrees. So 90 upon 360 total angle, right? There are 4 atoms into 4, right? This is the effective number. Okay, so effective number into pi r square upon area of square, that is a cube, a square is a square, right? And a square value is, since a equal to 2r from figure, it's clearly seen, right? So a equal to 2r, so a square equal to 4r square. So we'll write 4r square here. Okay, 4r square. So we'll simplify it. So this is going to be 4 will get cancelled. Okay, this 4 get cancelled. This value is going to be 5 by 4. R square will get. Okay, so for this structure, the atomic packing fraction is 5 by 4. Okay, guys. Well, so guys, the crystal structure is completed, right? So I'm going to stop here, guys, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, guys. Okay, guys. So thank you so much. Bye now.